back, guys. Today we are back with another problem. Today's problem is an array to binary search tree. So what is today's problem? We can see that we will be given an array and then we have to convert it into a binary search tree. So we'll be given an array. So what type of array this is? This is a sorted array. Okay. So we will be given a sorted array and we have to convert it into a binary search tree. Okay. And also it is saying that given the root of the binary search tree, height balanced binary search tree means tree in which the depth of the left subtree and the right subtree of every node differ by more than 1. So if you see the depth of the left and right subtree is differed by 1, 2 is differed by 3, 3 is differed by 4, and like this. Okay. Similarly, if you see a binary search tree as like this, so how we are going to solve this? We are going to solve this using a optimized recursion method. So we can write it like we are going to solve this using optimized recursion. Okay. So what type of properties we are going to use and all those things I'm going to explain. Okay. So first let us come with the array which is given in the question, which is a nums array. So if I see the nums array, my array is 1 to 7 in sorted order. Okay. So 1, 2, 3, 4, 5, 6, 7. So if I see 1 to 7 in sorted order. Now I have to do the pre-order traversal of the binary search tree formed by this particular array. So what I'm going to do is I'm going to make an algorithm which will help me solve this particular problem. So initially I will be checking whether my first my base case will be like if whether there is any element or not. So if the value is if the value of the nums array, if the nums array is equals to null. Okay. So in this case I'm going to return a false. Okay. Or my nums dot length means my total length of the array is equals to 0. In that case also I'm going to return a false. Okay. So in both the cases I'm going to return a false. But what about some other case? What about some other case? So let us come to this. Let us consider this case where it has some values, which is the values are from 1 to 7. Okay, values are from 1 to 7. So in this case, what we are going to do is first we are going to take the middle position. So the middle position, we are going to have a middle position equals to left plus right minus of left by 2. Okay. So initially my left is equals to my 0th index. Okay. So my left is equals to my 0th index. So I'm going to just signify the indexes over here so that it becomes easier. So this is my 0, 1, 2, 3, 4, 5, 6. Okay. So initially my this thing is my 0th index, right? So what basically I'm going to do is I'm going to find the middle value. So I can write mid equals to my left, which is 0. Okay. And right minus left. So what is right? Right is nums dot length minus 1. Okay. So what is nums dot length? Nums dot length is 6 minus 1. Okay. So it's like, so what I can basically find is from this particular thing, I have to find the middle index, right? So if I see this particular question, my middle index should be for the middle index over here. The middle index should be 0, 1, 2, 3, 4, 5, 6. So which is at 3. Okay. So what I can get is I'll get the middle index. I'll directly get the middle index without adding unnecessary details. My middle index is equals to 3. Okay. So now I have to find the node value at 3. So I can create a node root. Okay. Node root equals to new node. Okay. And I'm going to pass the mid value. Okay. What I'm going to do is I'm going to pass the mid value. So when I'm passing the mid value, my root becomes third at the index 3. So at index 3, what element do I have? What element do I have at index 3? I don't have to go there. I can just directly check from here. Yeah. So at index 3, I have 4. So my first node is 4th node. So this will be my first node. Okay. Now from here, I have to decide what I'm going to go to the left. I'm going to go to the right. Okay. So before that, I have to think of another way in order to traverse to it. So what I can write is root, right? So root dot left, okay, equals to what I can pass the function, say binary search tree. Recursively, I'm calling the function so that the loop is getting executed. I'm going to call the nums array. Okay, the nums array will be there, and the starting index and the final index. So if I see what is going to be my starting index, it is the left, and I'm going to go till mid minus 1. Okay, I'm going to go from left to mid minus 1. So left to mid minus 1. Okay, so this is how the thing will work. So initially we are at 4. Okay, so that means our starting position is 0. Starting position is 0, right? 0. From there, if I have to check what is mid minus 1? So mid value is 3. So mid minus 1 is 2, which is at index 2. So index 2, which value is there? 3. So I have to just check. Yeah. So my index mid value is 2. So when I'm getting the mid value, first I have to check what is the values I'm getting. 4, 2 and 6, right? So in this case, when I have a value as 4, so in the initial call, what we can see is 4 is there. And in the first level of recursion, what we can see is we are getting the left and the right subtree. Okay, so we are getting the root 4 already, that's done. Okay, now the first level of recursion is being carried out. Okay, so in the first level of recursion, what I can see is my left is equals to 0. My left is equals to 0. And what is my left is equals to 0, and what is my right? So in this case, what I will divide this into and left and right subarrays. Okay, so if I divide this, how am I going to divide it, and how is going to look like? So this is middle position. I'm not going to disturb my middle position. So this is my left, okay, and this is my right. This is my left and this is my right. So once I'm getting the left and the right, what I can call is, I already have a left equals to 0. Okay, left is equals to 0, and my right is 2. Okay, so my middle index. So if I want to find my middle index, which is left, okay, which is 0 plus 2 by 2, which is 1. Okay, so now you'll be asking, and how are you getting to? So right is equals to, which is for this particular array 1, 2 and 3, my length is 3, right? And 3 minus 1 I have to take. So 0 plus left plus right minus left. So what is right? My right is 2. Okay, divide by 2, which is 1. When I'm getting right as 1, when I'm getting the middle value as 1, so this is not just a second, this is just not right. I'm going to write this as the middle value. So my middle value at 1. So if I'm getting the index at 1, what is the value present at 1? 2. So my mid becomes 2. That means this root is updated to 2. Okay. When my root is updated to 2, now I have to think of the other subarray. The other subarray is 5, 6, 7. Okay. Now let us take the example 5, 6, 7. In this, the indexes are 4, 5 and 6. The indexes are 4, 5 and 6. Okay. Don't confuse with the indexes. So in the case of 4, 5 and 6, the left is equals to 4. Okay. And the right is equals to 6 minus 1, which is 5. So mid equals to, if I check, my mid will be 4 plus 6. So 4 plus 6 by 2. So in this case, I will get a middle value at 5. So what is my index at 5? 6. So what I can get is, my right subarray's root will become 6. So this is how the root is being constructed. Now again I will have to reconstruct it using my second level of recursion. So in the second level of recursion, what basically I will see is, this was my first level of recursion. In the second level of recursion, what I can see is, I have to first check my left subarray, which is 2. So if I'm getting 2, the elements, if my value is 2, what is there to the left? 1. Only 1 is there, right? So if I have only 1, that means over here I'm going to have a left as 1. Okay. So now any value greater than 1 on the right side is 3, right? On the right side is 3, because this is going to follow a pre-ordered traversal. Pre-ordered traversal means this value has to be lesser than this value, and this value has to be lesser than this value, and this value has to be greater than this value. Okay, so this is the pre-ordered traversal. So if you have got the pre-ordered traversal correctly done, what basically next you are going to do? You are going to go for the second level of traversal. So in case of 2, you got 3. Now consider the left subarray as 6. So in the case of 6, what you have is a 5. Okay, for the left subarray 6, what you have the value as 5. So in case of 5, your left is at index 4. Your left is at index 4. So which means your value is at 5. Okay, and right is at 4. So right is also at 4. Correct. Right is also at 4. So in both the cases, what you can see is, so your mid will be from left to right. So your mid will be nothing but 5. Okay, so you will get a middle value as, you can see in the diagram. Yeah, you will get a middle value as 5, and then another subtree is child is left, which is 7. So this is how the entire BS binary search tree is completed using the algorithm we worked on. Okay, now let us try to implement this algorithm in the code. So if I just see in this particular code, I'm going to reframe and rewrite the code, so that will be easier for us to consider it. So you will be having a node sorted array. So first my target will be if my nums dot length, len length, is equals to 0, or nums equals to null. In this case, I'm going to return a false. Okay, I'm going to return a false. Else 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 I'm going to return the convert BST function. In the BST function, what I'm going to pass? I'm going to pass the nums. I'm going to pass the starting index. I'm going to pass nums dot length -1. Okay, so both the cases are done. After that, what I'm going to do is I'm going to have a public node, and the name of the function is convert VST. In the convert VST, what I can pass is a nums array. Okay, I can pass the left side and I can pass the right side. Okay, once this is done, my first target is I have to get the mid value. So mid is left plus right minus of left by 2. So if I get the mid, what will be my next following target? So I have to make a new road equals to root new, I can say new node. I can pass over here, I can pass the value of mid. So I'm making this as mid. Now root dot left is equals to convert binary search tree. I'm going to pass the nums array and left and mid -1. Similarly, root dot right equals to convert BST recursively. I'm going to call nums, and I'm going to just check what I did. I'm going to have from middle value middle +1 to right and return root. Okay, I also have to keep a base case whether my this was the, if you haven't seen the previous video, you can go and check whether this is the condition for binary search tree. If my left is greater than 1, right, that means it is not a binary search tree because my left cannot be greater than right. Okay, so compile. So I have to put a bracket. Return false. So if the null value, return null. Okay, so let's compile. Submit the solution. So we have successfully completed today's problem statement, and I hope you like this solution, and we are looking forward to solve more videos. Thank you.